Okay, so on our chart, we had our parallelograms, right? So, if I can get my marker off. Okay, so we had parallelograms, squares, rectangles, and again, area is base times height, and perimeter is just add up the sides. Okay, and again, you can have, funkier formulas for that if you want. And then we talked about TRs, which remember were triangles and trapezoids. And basically, they have similar formulas. For triangles, area is half base times height. And again, we talked about different reasons why. Doubling and making a parallelogram, or filling in the rectangle and only having half the area, or cutting the top off the triangle and making a parallelogram that has half the height. But again, that was in another video. And then perimeter would just be add up the sides. And then for a trapezoid, if you want, you can use the same formula, except use half capital B times H, because technically you have two bases. You have base 1 plus base 2. And again, on that one, we doubled the area. So we copied it, flipped it over to make a giant parallelogram, and did that. And again, perimeter, you can just add up the sides. So at this point, the only thing we had left the other day was circles. And so I'm going to erase all this, and we're just going to focus on what we did, kind of summarize what we did the other day. So with circles, it's kind of easy to remember the formulas. Clowns get pied in the face. And so if you have a circle, remember the diameter divides the whole thing. A radius is kind of like a ray of an angle. It's just the partway amount, okay? So I think it's easier to remember this. Clowns get pied in the face. Sometimes people to put 2 pi r, like where the diameter is, they put a 2 radius here. But if you think of that as circus clowns get pied in the face, that's easy to remember. And remember, we discovered that. And again, if we were in class, it would have been way better. And so I apologize for that. But if you had, in class, I would have had you really big circles, really little circles, maybe a giant circle on the floor, all sorts of things. And I would have had you take string with your group and wrap it around and mark it off. And then I would have had you measure that string on a ruler. And then I also would have had you measure the diameter with a ruler. And so I would have had a chart where you had, all these different shapes, like a cup and Julie's thing that keeps all her paper clips in, and just all sorts of things. And I would have had you make a chart for that. Okay, so you would have had something like the object here, and then I would have had you do the circumference here, and then the diameter here. And then I would have had you divide the two to see what you got. So you might have had, the big circle, and you measured it, and maybe when you divided, you got 3.09, okay? And then you would have had maybe a cup, and you would have had this number and this number that you would have got with your measurement, and maybe here you got 3.25. And then maybe you had the giant circle on the floor. I think sometimes I even brought in the giant water bottles from our filtered water in our office. So again, maybe you measured the bottom of that, and you divided, and you got 3.16. And so we would have done that in class, and then I would have had you look at that last column, and I would have asked you, what is that? And the answer to what that is that should have been pi. And in class, if you would have done that, you would have not, you would have been off, because measurement isn't perfect. Humans aren't perfect. But in reality, all of these answers should be exactly pi. So if you take the circumference divided by diameter of any shape, you should get perfectly pi, which is an irrational number. It's 3.14159, and it goes on forever and ever. It never has a pattern. It's just not going to be nice. And so if we would have discovered that in class, right, and we tried to do that with that app online, but it did not work very well. So circumference divided by diameter is always pi. And so if we do a little bit algebra, that's how we can discover that formula right there. So circumference is that. And then for an area of a circle, we got pi r squared. And again, I liked the app we used online for that. So what I had you do physically is I had you take a circle and cut it in half, and I had you shade part of it, right? Half of it. And then what we did is it's not a very good circle. Then what we did is we cut it in half. So I had you cut this much of it. And so then we had 4 pieces. And so what we tried to do is kind of do one of these deals. And then you put the shaded ones in here. All right. And our goal was to get back to a rectangle. And so that wasn't super accurate. So then we folded these all in half again and cut them in half again. Right? And so then maybe it looked a little bit better, but maybe not great. And again, then that online tool was great for showing this. I felt like the circumference activity I tried online did not work. But then I really, really did like this one, because as humans, we can't cut it into like 1,000 pieces, but a computer can. And so eventually, if we cut it infinite many times, eventually we're going to get a rectangle. Okay. And these little teeth are going to be, basically infinite many, thin. Okay. If we could do that. And so if you think of what happened with our circle, we took the top of it, and on that app, they did a good job of, they took the top at the halfway mark, and so here's your little, teeth. And then there's the second half of it with the teeth there, right? And then they rolled that back up. And so if you look at this, unrolled, this is your circumference, right? If I unroll all of this with my teeth, that's the circumference. But then notice we flipped these guys on top. So this bottom part was just half the circumference. And then as far as the teeth go, if we infinite many cut that, that is these little half cuts here. Those are the radii. And so if I keep, cutting, so this is skinnier and skinnier and skinnier, same thing over here. So my teeth are microscopic. That height eventually is your radius. And so that goes there. And so after we did that in class, then it was a matter of finding the formula. Well, circumference is pi d. So instead of this, I could put half of the circumference, which is pi d. But again, I don't want diameter and radius in the same formula. So to get rid of diameter, I realized that there are 2 radii in a diameter. If I cut a circle in half and I have the diameter divides the whole thing, that would be 1 radius plus another radius. So that's where that 2 radius comes in. All right, and then half of 2 cancels. So I really get pi r. So base times height. Remember, everything goes back to formulas you already know, which at this point is, for us, is a rectangle. So we have pi r times r, which is where the pi r squared comes from. And so we kind of discovered that. And so pi r squared, again, is kind of easy to remember. If you remember clowns get pied in the face in the circus, then area always has to have a square in it, like square feet, square inches, or whatever. So pi r squared is going to be for area, because you need to get square feet and so forth. Now, there was another app for area, and some of you at the beginning of class said, well, we also know the formula for a triangle. And that's true, we did. So we could go back to that formula we knew, and that app was, I thought it was super, super cool. But this was our circle, and it just kept undoing the layers like an onion. So it would make a new circle and then peel that back, and make a new circle and peel that back, and make a new circle and peel that back, and make a new circle and peel that back, and make a new circle, peel that back, and so forth. So it kept peeling back until you got a triangle. So it kept peeling circle after circle after circle, kind of like an onion, until we got a triangle shape. And notice this first circle, when it got peeled back, is the circumference. So that was the circumference. And then notice the height of our triangle is the radius of the original big circle here. So that's r. So again, we know circumference is pi d, which again, I can replace it with 2r there, right? And so the area of a triangle is half. My base is the pi and the 2r. And then the height is r. So again, notice the half cancels the 2, and I still get pi r squared, even if I go back to the formula of a triangle. Okay? And so either way, we always go back to formulas we know. So right now, we know the formula for rectangles, parallelograms, squares. We know triangles, and we know circles. So at this point, I could give you weird shapes. Like I could give you a shape that looks like this, maybe this, and maybe that. And you should be able to, and pretend that's a semicircle there if I could draw. So you should be able to find, if this is a shaded shape and I want to know the area, or the perimeter for that matter, you should be able to figure it out. And so you might have to, you know, look for numbers. And so, you know, you're going to be like, okay, well, you know, if this is 10 feet by, say, 4 feet, that's a rectangle. So you're like, okay, I can find the area of that. And then here, you're probably going to need to know this side. So maybe this is 6 feet. So then you're like, okay, well, this is a half of a circle. So I'm going to use pi r squared, but I'm going to have to take half of it because I only have a semicircle there. And then for this shape right here, you're going to be like, okay, and again, somehow you're going to have to know. So maybe this is like, maybe this is 6 feet from here to here. So then you're like, well, if this is 10, this is 6, then you know that guy. And then maybe you know, possibly, maybe you know all of this is 12 feet all the way across. So then you might have to look up here and say, well, then that's 4 to there. So this must be, what, 8 feet over here. And then for this triangle, you have a triangle in there. You could do half base times height. And then you could add up all 3 of those to get the area. And then as far as perimeter goes, you know this, you know this, you know this. You know all that's 12, so that's great. So then really all you'd have to do is half circumference. And I could just put half pi d to get this part. And then again, perimeter, you just add up the outside. So you take 6, 4, 10, 12, and then half whatever pi times the diameter is there. So the nice thing is if you basically know these 3 categories in your chart, you can pretty much do any single problem of any shape by cutting it into shapes that you know. And there are other formulas out there. In trig, we have some formulas for area of triangles. Geometry, we have some different ones besides these. But these are the main ones that we want kids to understand, and basically understand that area is cuttable and that perimeter's not. Like perimeter, you're kind of stuck with your original shape. Those are big ideas that we want kids to get. All right, that's the summary, and I will post this, and we will keep moving on.